There are so many collections. As I discussed, as I detailed in the last class, there are so many collections, and you are familiar, and literally you used to use the term collection. So many collections are there, but all collections are not set in view of mathematics. So in mathematics, all collections are not set. Those collections are set where objects are well defined. And I explained what well defined is, the meaning of well defined. I illustrated earlier that well defined means what you are going to collect, what collection you are going to make on that objects, on that elements. You have to put some condition that I am going to collect this kind of things. We are going to indicate this kind of objects. So, what kind of objects, what kind of elements you are going to collect, it must be defined properly so that to to say the elements or objects of the collection, or to pick up the elements or objects of the collection, you do not have any problem, you do not fall in any confusion. So that's well defined. And some examples we discussed yesterday, last class, like collection of some students or collection of all students from your class, from your college. These are well defined collections set. Collection of books from the library, it's a collection well defined because some books are there in the library. Any particular book you can pick up. So these are well defined. And collections of members of any particular committee, collection of some defined objects in certain group, collection of natural numbers, integers, collection of even numbers, odd numbers, real numbers, rational numbers, irrational numbers, complex numbers. These are defined. So these are set. And standard notations also given, shown in the screen in the last class, that n, capital N is always set of natural numbers, capital Q always represents a set of rational number, capital R stands for real numbers, capital I or Z as a set of integers. So these are standard way symbolized. So some collections also I mentioned in the last class which are not set. So collection of new Hindi films, collection of beautiful girls of your section, of your class, of your college, collection of wise men from the society, collection of dangerous animals from the planet. So these are not set because here objects are not well defined. Who is beautiful and who is not beautiful, you cannot measure. There is no yardstick, and that cannot be quantified. Who is actually beautiful and who is not beautiful, who is handsome and who is not handsome. So it cannot be measured in terms of number, in terms of value. So that's why these are not well defined. Wise men, collection of wise men, who is wise and who is dull and who is foolish, you cannot determine this, and there is no yardstick to measure. So it's not well defined. Collection of new Hindi films. Which particular films are new? You cannot define this. From which particular date? After which date, whatever films released, these are known as new. So definitely not. So, so it's definitely not well defined. Dangerous animals similarly. So which animals are dangerous, you cannot identify, and which is not. At particular moment, suddenly a cockroach might be dangerous for a particular person. So dangerousness you cannot measure. So these are not well defined. So these collections are not set in mathematics. So after that, we have given some examples of sets, some collection of some numbers we have got in the last class, and so representation. Now, after definition and some examples, representation we just mentioned in the last class. How we represent it, how we express, how we write, that is the representation of set. So two forms are there to represent sets, and one form is tabular form or roster form, and in both the forms, tabular and set builder, both the form we must express within second bracket. We must express within second bracket. Now see, in the within the first bracket, if we write elements, that is roster form, and set builder form is little bit different. And apart from this, we discussed in the last class also about a symbol, as you have seen in the screen, uh, to express belongingness of an element in a set. That symbol is here. Epsilon, name of the symbol is epsilon, and read as belongs to. You see here, A is an element of a set, and we say that A belongs to A. Capital A is set and small a is its element. So simply we read as A belongs to A, but it is written as this: A epsilon, A epsilon A. Epsilon means it is a symbol from Greek letters. So it is symbolized as A epsilon capital A. This means small a lies in the set capital A. Small a is there in the set capital A. Read as A belongs to capital A. Read as A belongs to A. So here in the screen you have seen the two methods of representation of sets. Number one, roster or tabular form. Roster or tabular form, and second method of representation is set builder form. These are the two ways in which we used to write set. We used to represent a particular set. Only these two ways we used to represent a set. Here you see in this number one, in roster form. Not only in roster form, in both the forms, second bracket is compulsory. Whatever elements, whatever objects we want to express, that objects or elements we must write within second bracket. Here you see in number one here, second bracket is compulsory. Within second bracket, three elements are written: 2, 4, 6. Whatever elements you want to write, you can write. So 2, 4, 6. And you see here between two elements a comma is there. This comma is very much essential because this comma differentiates the elements. That means distinguish the elements. So comma and second bracket compulsory to represent a set in tabular form. Here in this example 2, 4, 6, and it is a small a. It is another example. This is set of all natural numbers which divide 42. It is another example. Set of all natural numbers which divide 42. That is all factors of 42. By which numbers we can divide 42 with remainder 0, divisible. So all the factors of 42, it is written within second bracket like this: 1, 2, 3, 6, 7, 14, 21, 42. So all these factors are written within second bracket using comma. So this way, when we express, it is called roster form or tabular form. We need to use comma and second bracket. It is compulsory for roster or tabular form. And it is not mandatory to write the elements in particular order. It may be in different order also. Set will represent same set. It is not mandatory to write the elements in certain order. So randomly we can express the elements, which is first element, which is second element. That is, order of the writing elements is immaterial. Just all the elements, whatever we have to show, must be there within the second bracket uh, without maintaining any order. Just inclusion of all elements is essential. No element should be left out. So order of writing elements inside the second bracket is immaterial. Similarly, B, it's another example, small b. You can see in the screen, B, the set of all vowels in the English alphabet. So literally already it is said that collection of all vowels from the English alphabet, this is a set. Literally we can say this collection is a set. To express it, we have to write like this. Within second bracket, just write the vowels distinguishing by comma. So A, I, O, U. So this is the representation in tabular form. Similarly, another example here you see number C. The set of odd natural numbers is represented by 1, 3, 5, comma, dot, dot, dot. So this is also in tabular form, because within second bracket we have written all the elements within second bracket using comma. So this is also in tabular form, 1, comma, 3, comma, 5, comma, dot, dot, so on. Is the set of odd natural number. And this dot dot means it is up to infinity, nowhere ends. 1, 3, 5, 7, 9, 11, 13, 15, so on. So this is up to infinity. That is, limitation of elements is not restricted. Infinite number of elements also might be there in a set. So in this way we used to represent tabular form or roster form. Next, in number 2 method of representation of set, that is set builder. So in the representation of set builder, it is a little bit different. As just way of writing the element, way of writing the set, it's little bit different. Same example, we pick up, suppose the collection of vowels, which is in tabular form. We write within second bracket A, E, I, O, U. So it's set in tabular form. Same set, if we want to express in set builder form, then we get like this. Suppose the set of vowels, the name of the set is, suppose V. So V is nothing, just its name of the set is assumed. It's no problem. That's because usually we denote the sets by block letters. So any block letter you can use. So it's suppose V is the name of the set. Okay, how to write this set? You see here within second bracket. Again, within second bracket it is compulsory. This is the structure of set builder. X. We started writing within the second bracket like this. X. Then a symbol is there, colon. And then written X is a vowel in English alphabet. Bracket close. So this is the way of writing set builder form. First, X represents all the elements of the set. This X represents all the elements of the set. What about the elements? It's about the elements, informations about the elements sufficient information characteristics you must mention after this sign colon. After colon sign, you have to mention about the characteristics of this x. You know, if x represents all the vowels, so about this x we have to express after such that. What is this x? This x is vowel. X is a vowel of English alphabet. So this is actually definition of the element. What first x is to express after colon. X is a vowel in English alphabet. That is, first x represents all the elements, and after colon you have to define about x. That means about the elements. This after colon, this must be properly defined so that all the elements are, no element is missed, and properly indicate the same elements. So this is the way. So everywhere in set builder form, we have to start with x within second bracket, x colon, read as x such that, x colon, and then we need to write about x. What is x? You have to write about after colon sign. This is the way of writing set builder. Another example, you see, just 1 minute. A little bit technical problem. Okay. Am I audible now? Am I audible?
Sir.
Yes, sir.
Yeah. It's actually technically problem. The screen was gone. Anyway, another
Yes, sir.
example of set builder form. You see here, this A, capital A in the screen. Capital A is equal to X such that X is a natural number.
Sir, নাই দেখা sir.
Uh, Screen is not visible.
Yes, sir. Not visible.
Screen is not visible, no?
Sir, start করলো sir.
Is it visible for the other students?
Yes, sir.
Huh?
Yes, sir.
Yeah, it's visible. Yeah. A here, you say X such that X is a natural number and 3 less than X less than 10. This is the condition, and second bracket close. You see here very carefully. A is equal to X such that X is a natural number and X greater than 3 less than 10. Now you see here, first X, as I told you, first X represents all the elements. Now what is X? About this X explained after such that, after colon sign. X is a natural number. Okay, no problem.
Yes,
Natural number, and the numbers X must be less than 10 and greater than 3. Less than, that means what are the elements here? It is distinctly defined x is natural and the values of x, that is the numbers, are less than 10 and greater than 3. That means 4, 5, 6, 7, 8, 9. This A set represents the elements 4, 5, 6, 7, 8, 9 because x greater than 3 and less than 10 and x is natural number. So very distinctly defined here after such that, after colon sign. So this set definitely gives us the elements 4, 5, 6, 7 and 8, 9. So this is the way how we represent in set builder form. Some examples here you see x. A is equal to x such that x is a natural number which divides 42. B, another example, y such that y is a vowel in the English alphabet. C, z such that z is an odd natural numbers. In all these examples, here you see how it is expressed. Within second bracket, first x, sometimes y, first x, after that colon, and after that about x, characteristics of the elements are defined, distinctly mentioned, so that we do not have any problem to know the elements, to have the elements. Here you see in the first one A, x is a natural number which divides 42. That is all the factors of 42 as we got few minutes back, same example. So exactly that numbers are given by this set. Second one, y is a vowel in the English alphabet. Already we represented in tabular form. Within second bracket, simply we write the vowels A, E, I, O, U. Within second bracket, that's a set of vowels in the English alphabet. That representation was in tabular form or roster form. Now, same set is represented here in set builder form. Y or x, you can write x also, no problem. Y such that y is a vowel in the English alphabet. This B set also representing same elements A, E, I, O, U, all vowels. Again Z, see, Z is an odd natural number. Z such that Z is an odd natural number. So this is the set which is the collection of all odd natural numbers. Again, this set also we have already written in tabular form. Yeah, tabular form or roster form. 1 comma 3 comma 5 comma dot 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 so on within second bracket. So that was already we have got in tabular form or roster form. Same set of odd numbers is written here in set builder form. Now say example, another example. Here it is. The right solution of the solution set of the equation is, this is quadratic equation. X square plus x minus 2 is equal to 0. And we need to express in roster form, tabular form. So this is quadratic equation. So we can solve it and we will be having two values of x, two roots of x. And that two values directly we can write within second bracket. That's all. And this equation just solved here. Two values, 1 and minus 2. So solution of this equation 1 and minus 2. So simply just it is written within second bracket. 1 comma minus 2 within second bracket. So that's all about its solution set in roster form.
Thank you, sir.
So next in the example 2 you see here, it is given, this example 2, it is given the set in set builder form. Write the set x such that x is a positive integer and x square less than 40. This set is given in set builder form, and same set we need to write in roster form. That means within second bracket we need to write the elements. We have to write the elements of the set which is in set builder. Here you see how the elements are defined. Elements are defined by this line. X is a positive integer. Okay, we understand x must be positive integer. Next what? X square less than 40. That means those numbers, if we make square, it must be less than 40. So if we put 1, so 1 square means 1 less than 40. So it is one of the elements. If we put 2, then it is 2 square, and 2 square less than 40. So 2 is also its element. If you put 3 here, 3 is a 9, 3 square means 9, 9 is also less than 40. So 3 is also its element. So in this way we can just check whether given condition is fulfilled or not. Simply checking, we can write the values of x within second bracket. If we put 1, 2, 3, 4, 5, 6 also, 6 square means 36, and 36 is less than 40. So therefore 6 is also element. We cannot include 7 because if x is equal to 7, then x square means 7 square. That means 49, and 49 is greater than 40. So we cannot include 7. So only elements are from 1 to 6, and just we need to write the elements here within second bracket. This is roster or tabular form. 1, 2, 3, 4, 5, 6. So this is the same set. It is in roster form, and which is given in the question, that is in set builder form. Again, this was set builder form to roster form, we can have the elements like this. In the next example, observe 3. A is equal to 1, 4, 9, 16, 25 comma dot dot dot. That is so on up to infinity. This is definitely within second bracket, all the elements are written using comma, so it is in roster form, tabular form. We need to express in set builder form. How we express this set in set builder form? Before that, if you observe the behavior of the elements, you will have this is 1 square, this is 2 square, this is 3 square, this is 4 square, this is 5 square. And next elements will be 6 square, 7 square, 8 square, like this. So this is the behavior of the elements. So we need to know about the behavior of the elements because we have to define in the set builder form. So we may write here like this. A is equal to x such that x is the square of a natural number. X is the square of a natural number. So obviously it is well defined. X is the square of natural number. It means square of the natural numbers are there in the set. Obviously this is 1 square, this is 2 square, this is 3 square, 4 square, 5 square. The square of the natural numbers are here in the set. So just that definition we need to include in the set builder form. X such that what about x we need to write here, and exactly that is written that x is the square of natural numbers. Or symbolically or mathematically we can represent same set in set builder form also. Same set we can represent mathematically like this. X such that instead of writing this statement literally, we can write it in this manner. X such that, what is x? This x is equal to n square. This x is equal to n square. Now what is n? N is natural number. N is natural number, so n belongs to n. We have to associate this part because simply x equal to n square if we write, again question will be coming about n. N may be any number, and after all no information about n is given. So that's why if we express with the help of another algebraic letter or variable or any other parameter, if we use to define the elements, that new alphabet or any variable or parameter, whatever we use, full information about that must be there. So if we write x is equal to n square, about n must be there, otherwise definition will not be complete. So n belongs to n, that means n is natural. Now definition is complete here. You put the natural numbers here in place of n, you will get all the elements. If you put n equal to 1, so x equal to 1, n equal to 2, x is equal to 4, n equal to 3, x equal to 9. So thus 1, 4, 9, 16, all these elements of the given set will be represented by this set. So this is also alternative way of representation. In the first representation, it is just written literally the condition that x is a square of natural number, and this literal statement we can write mathematically in this way also. Now you can understand what actually set builder form is. So two
Yes,
representations
sir.
we have. Yes, someone is speaking. Go ahead. Go ahead.
Hello.
You can proceed. Go ahead.
Sir, voice is not clear. Hello, sir.
What's not clear?
Voice, sir. Hello, hello, sir.
Yeah. Am I not audible?
Audible.
Okay. Do you have any problem for other students? Rinki, are you here?
So we are hearing.
You are hearing distinctly?
Yes, sir.
Yeah. It's okay. It's almost session is over. So we have discussed actually about the representation of sets. One is roster or tabular form, another is set builder form. In roster form, just we have to write the elements using comma within second bracket, and in set builder form, within second bracket compulsory, and the structure of the writing the set is a little bit different. We have to start with x within second bracket x such that colon, that means such that about x the sufficient information must be there, then second bracket close. The sufficient information about x means that is x represents all the elements of the set which are not visible. That's why just I have to define the elements after colon x such that about x we have to express there literally sometimes, and sometimes mathematical expression, symbolic expression might be there. So after all, about x, that is about the elements, it must be well defined after such that, after colon, then close of second bracket. So this is the way of set builder form, and it is I do hope you have understood. And as I told you earlier, you can go through the textbooks of NCERT class 11 standard, and same portions I am picking here also, and so definitely you can understand very clearly if you go class wise or topic wise whatever discussed, and if you follow it up immediately from the books, or you can search from the internet also, but whatever you listen exactly about that particular subtopic you have to search, or you have to study. So that's all for today, and next in the next class we'll discuss about the same topic with some numericals, some basic examples with basic recapitulation uh, of the sessions discussed here today. Thank you so much.
Thank you, sir.
Thank you, sir.
Thank you, sir.